Okay, so this video is addressing a few different homework problems I received emails for. This first one is section 1-2, problem 14. It states the table to the right shows the electricity rates charged by better than lighting utilities in the winter months. Part A requests that we write a piecewise definition of the monthly charge, and we're going to name the function w of x for a customer who uses x kilowatt hours in a winter month. Part B says determine the graph of Wx. So up here, the base charge is considered a fixed charge. That means you're going to pay that amount as a starting point for having the connection, and then you're going to pay based on how many kilowatt hours you use. It says the first 300 kilowatt hours or less, you'll pay a rate of 0.065 per kilowatt hour. And if you exceed 300 kilowatt hours, you will pay a rate of 0.09 per kilowatt hour. But this only applies to hours above 300, to kilowatt hours above 300. So let's start writing our function Wx. We give it a brace because we're going to have two definitions. The first is 6.50 plus 0.065 times x, where x is the number of kilowatt hours. And this is good for 0 being less than or equal to x and x being less than or equal to 300. So this describes the domain of this definition. So what happens when we go above 300 kilowatt hours? Well, first we have to calculate how much is 300 kilowatt hours. So we're going to say 650 plus 0.065 times 300. Let's plug that into a calculator. 650 plus 0.065 times 300 gives us 26. So that means that someone who uses exactly 300 kilowatt hours will pay $26, and that includes the base fee and the 0.065 per kilowatt hour. That means that this next function is going to start at 26, and then add to that 0.09 times, we said only for kilowatt hours above 300, so we're going to say x minus 300. And that would be our second definition, and this would be for 300 less than x. So this gives us our complete piecewise function. This is definition number 1 up here and definition part 2, and they each belong to their own domain. So if somebody were to use less than 300 kilowatt hours, say 250, you would use definition 1 and plug 250 in for x. And if someone were to, say, use 350 kilowatt hours, you would use definition number 2, plug 350 in for x. 350 minus 300 would be 50, so you would multiply 0.09 by 50 and add that to 26. And that's how the piecewise function would work. Now part B is asking that we find the graph. And the graph in Pearson My Math Lab, if we look at this, counts all the way up to 70, but it counts by intervals of 5 for each tick mark. And then the graph on this end of My Math Lab counts by intervals of 100 and goes up to whatever number. So basically what the graph is saying in My Math Lab is plug in values that are multiples of 100 in for x. So if I plug in 0, I would use definition number 1. Plug in 0 would start at 650. Since this is counting by 5, we would be right above 5. It would be at 650. And if we did 100, we'd still be using the first definition. 100 would move the decimal point 2 places, and that would be 650 plus 650, which would be $13. So we would be somewhere around here. And we would graph this way up until we got to 300, which would give us $26. So 1, 2, 300 would be here, and we would say 5, 10, 15, 20, 25, and it would be just a smidge above it. So we have a graph that starts like that. After 300, we would plug in, say, 400 into the second definition, and if you plug 400 in, 400 minus 300 gives you 100. Multiply it to 0.09, moves the decimal 2 places. That would become 9 plus 26. That would put us at 35. 5, 10, 15, 20, 25, 30, 35. And we see that the graph would then start to move at a higher slope. So that gives us the shape of our piecewise graph, and you should be able to match it up with the options in my math lab. The next question I got was from section 1.3, problem 16. And it says let f of x equal 0.8 times x squared minus x minus 6. And it says solve each equation graphically to do 2 decimal places. So what that means is you're going to take your graphing calculator, go to the y equals, and you're going to plug f of x in for one of your y equals, so 0.8 x squared minus x minus 6. And then for my second equation, for part A, I'm going to enter 4. And let me go back to this for a moment. Remember, we've been saying that f of x could be replaced by the y variable. So it means we have y equals 0.8 times x squared minus x minus 6. And that's why we put that in y1 of our calculator. And then here we have y equals 4. We put it into the y2 of our calculator. Remember, this is a horizontal line. And this is a parabola. Because the front number is positive, it opens up. And if I plugged 0 into all of my x's, it would cross the y-axis at minus 6. So it's a parabola that opens up with a y-intercept equal to negative 6. So this parabola opens down. This parabola opens down. Over here, I have 2 parabolas that open up. I see the x-axis is here, so it looks like this could possibly be minus 6. And this one, I have the x-axis is here, so this could possibly be minus 6. So now we have to look at the other graph. Y equals 4 will be above the x-axis. This horizontal line is above the x-axis. This horizontal line is below the x-axis. So this would be the correct graph that shows the intersection of f of x equals 4 with the parabola. And we can solve for this in our calculator by hitting graph. So we see the parabola, we see the line of f of x, and now we can do second calc menu. In blue, you see it's in calc, and option 5 is intersect. And we're going to bring our little crosshair close to where the intersection is on the left side of the parabola, and we hit it 3 times. It tells me x is negative 2.965. So we'll round that to say negative 2.97. So x equals negative 2.97. And if I go back, I can do the second calc, and option 5 is intersect, but this time I'll move my cursor to the other side of the parabola where the line touches on the right side. I get my crosshair close to it, and I hit enter 3 times, and it tells me x is 4.215. So say I'll round to the hundreds and say 4.22. So that's my x1 and x2. If they ask for these answers, it says to 2 decimal places, so that's correct the way I generated the answers. And that's how you can use your calculator to do this, solving it graphically. And the last question I got was section 1.3, problem 17. It says under certain air conditions, the air temperature drops about 3.9 degrees Fahrenheit for each 1,000 foot rise in altitude, and it asks that we complete parts A and B below. So part A says if the temperature at sea level is 63 degrees Fahrenheit, write a linear equation that expresses the temperature T in terms of altitude A in thousands of feet. So it expresses means output, temperature, so the output is T, that's like our Y variable. So Y goes to T in terms of, the phrase in terms of means your input. Well, the input is our X variable, and we're going to call that A. So instead of Y of X as a function, we're going to have T of A. And the last thing it says is in thousands of feet. So A equals 1 implies 1,000 feet. Great. With that said, we can see that part A gives us an ordered pair. It says if the temperature at sea level is 0 altitude, so our input is the altitude, that would be 0, and our output would be 63 degrees. In the directions up above, it says that the air temperature drops, so that's a negative 3.9 degrees for each 1,000 foot rise. So we have to remember slope equals delta y over delta x. In this case, our y is t, so it's going to be delta t over delta a because our x variable is replaced by a. Delta means the change in. So how is the temperature changing? It's dropping 3.9 degrees, so it's negative 3.9. And how is the altitude changing? 1,000 feet, so over 1. And remember, A is being expressed in terms of thousands of feet, so that's why I didn't write 1,000 there. So the slope equals negative 3.9. And because this has an x value of 0, that means that 63 is our y-intercept. And we can write y equals mx plus b as t equals, the slope is negative 3.9, replace x with a, plus 63 is our intercept. And that would be our linear equation for part A. Part B says, at what altitude is the temperature 8.4 degrees? So you're going to replace temperature, which is T, with 8.4 for part B. Once you plug that in, you have an equation, and you should be able to do the rest and solve for A when T is 8.4. Okay, so this is the end of the presentation, and I hope that helped.